Welcome back, guys. Much of Black. Yeah, we are now going on to do life assurance contracts. So, life assurance contracts, we are gonna deal with a few. I'm just gonna name four of them. So, most important is the whole life assurance. So, here a policy holder pays in some kind of premium, and when they die, we we pay a sum assured. So that's the whole life. The benefit is payable on death. The sum assured is payable on death. Have a term assurance. The For a term assurance, the sum assured is payable on death, provided it happens within a certain term. So if you buy a 5-year term assurance, if you die within the next 5 years, the payment is made. If you don't die after that, the policy lapses or matures. Pure endowment, if you survive, again, if you buy a 5-year pure endowment, if you are alive after 5 years, you get paid that. Then you have something called the endowment, and an endowment is combination of a term assurance and a pure endowment. So if you die within the 5 years, you get something. If you live up to the 5 years, you get something. Okay. Then you also have something called a deferred assurance, where the insurance kicks in, say, after a certain year, 3 years or so. So that's deferred. And then, so the most important thing um, we are going to deal with is the most important thing that we're going to deal with is for each of these, we are going to look at the random variable, which is important, the expected present value, and the variance, right? So that's all that we're going to look at and provide formulas for those. So as we start, we're going to start with the whole life assurance. So for the whole life assurance, the random variable is we're just going to PV that sum assured, right? And the KX is the random variable. We don't know when you're going to die. And we've also determined the PDFs of KX and the calculation and what it means in the life table. So we're not going to get into that. So that is the random variable. V is equal to KX plus 1. Um, you can include the S, but it's normally a 1, right? But as long as you define the S. So the EPV is that we now need to multiply this by K for expectation. We multiply the random variable by K, and then we sum it over some range, right? So expected value of this random variable is equal to this random variable multiplied by the probability over some range to infinity. We don't know when we're gonna die. And that simplified, we've just removing the probability of K to K bar 1QX, right? Because if there's nothing there, it's invisible. We just defined the P from the life table, and then we just gonna call that AX. Simple enough. we need to know that definition because in exams you can have to do it from first principles. Okay, the variance of this is a variance definition, V kx squared. So we're going to square the random variable subtract the square of the mean. Simple. And then we define those from first principles again. Um, we define these from first principles again. We just have v to the kx plus 1 squared. And then we introduce the probability, and then we've already defined the e of x. And then we know that the final value here is that, right? So we've just defined the variable squared, the expectation of the variable squared. We've just defined that as a subscript on the front, so it's 2x ax, right? And this ax is just the expectation valued at 1 plus I squared minus 1, right? Simple. We need to understand the definition. We need to understand the symbol and the calculation. That's it. Same here. Definition, first principles, assumption, and then the final definition. Okay, that's it. Term assurance is the next one. So for the term assurance, you define the random number. So we said that the term assurance, you get paid if you die within a certain time, right? After the certain time, the random variable is 0, right? So you get paid, so it will be similar to this. But then if your TX is greater than some n, you don't get paid. So it's VKQX. If KX is less than n and 0, if KX is greater than n. But we're still sticking to the principles of the whole life as our base. And the others are just going to be our controls, right? So that we're now going to define the expected present value. For the expected present value, you're still getting that it's the expectation of that random variable. It's now up to n and not infinity. And it's also as well, here we just define the probability of k and then introduce a new notation for the expectation, which is a xn1, right? So the 1 is on top of the x as a random variable, right? So that's the term assurance. We need to understand this term assurance because there's a lot of calculations from it in the exam. So the variance of this random variable, it's now a xn subscript 1, and then that's valued at 1 plus I squared minus 1, and then minus the expectation squared. Okay, so simple enough as well. We need to understand the formula, understand it from first principles. So the term assurance is really important. There's a lot of questions on it in the exams. You have your pure endowment. That's when you get paid if you live up to a certain age. So the random variable, you won't get paid from now up to term n, and then you're guaranteed to be paid if you live up to that. So it's 0 from now till n, and then when you reach n, you get paid your money. Note that there's no um, KX. It's guaranteed. Right. Um, we now move on to the expectation. The expectation of this is VN NPX. So we are going to pay you provided that you live to those years, right? And then we introduce the term. Note here the one is on top of the N to ensure that we're paying you. It's not dependent on the random variable or whatever reasoning was used to bring about these notations. Right, so for the variance, we have variance of G, same notation as the previous ones, which is your term assurance and your life assurance and your whole life assurance. Then you have the endowment. So for the endowment, we have that it's a term assurance plus pure endowment, which we've defined. And um, we're expecting a combination of the two, right? So the random variable will have some value whether we are less than or greater than n. So whether when we're less than n, it's the term assurance. When we're greater than n, it's the pure endowment, right? Same for E. Right, the E, the expected value is going to be equal to the expected value of the sum, and you're just gonna have the expectations of the two, first principle definitions of the two, and then we just have that value with the other one. That's an endowment, right? So for the variance, I won't touch on it now. When we do a question paper, I'll touch on it. But general definition of a variance, I think it's variance of F, variance of G minus 2 covariance of FG, right? That's in the orange books. So we have to calculate the covariance there of the two and then get a final value. But yeah, nothing scary as well, but there is a definition of that. I'd rather we don't touch on it now. We touch on it when we do our exam question papers. Cool. We have a deferred assurance. So for the deferred assurance, that's where the assurance kicks in after a certain time. So from now up to that time, similar to the pure endowment, you won't get anything. And then after the time, you get something, but with a random variable, right? So random variable there, you don't get something, you get it, but it's no longer v to the n, but it's a random variable. And then we now need to define the expectation or the expected present value of this, and then introduce notation as well. So the notation is n bar AX. So the n bar is just a difference, just like the n bar MQX, similar to that. So it's a difference. At that point, we were deferring the probability of death that you live. In this case, we're deferring an assurance. Um, Nothing special to see here. Let's keep it moving. The important thing is that when this is the assurance, right? So you have to live up to n years, right? And then if you live up to n years, you'll be x plus n, and then we bring that forward by the Vn. we bring it to today. So that's AX minus the term. So that's a term assurance there. So it's AX, the whole life, minus the part where it's going to start, minus the part where we don't have, which is that term assurance, and then you have the whole thing. So this is very vital when we're calculating the term assurance, right? Because you'd normally have this value and that value on the tables, and then you need to calculate that. So that's very important to know and understand as well. And then lastly, we have that the variance of this thing is just equal to this notation and that whole thing squared, right? And then you have immediate death benefits. Immediate death benefits so that's where you need to understand some integration. You need to understand your summations, but mostly integration, because you're gonna integrate a lot in this space. So we need to know our integration. So for immediate benefits, we define the function, right? So E of y, this is just a general statistical definition. So E of y is equal to the integral over whatever range of y minus that y multiplied by that probability over each range, and then you get a value, right? So we know that TPX, which is the lifetime random variable, the PDF, in this case normally is TPX UX plus T, right? So these two are important as we start defining, right? So if we define a whole life benefit, right, where the benefit is payable immediately on death, so the bar is at the top, right, to signify continuity. And then you have VTX. It's no longer KX plus one, because KX plus one is you die now with KX and then we pay at the end of the year. But in this case, we pay immediately, which is that TX. So we have to integrate that. We'd have to integrate that by V to the T and then TPX, right? So, and then the PDF. Okay, so that's the variable VT that. Okay, not bad, but does get bad. And then for the variance, same thing, but with the bars, right? So that's VTX. Take that. Okay. And then if we were calculating a deferred or a term assurance as well, we'd have it have a bar at the top, right? Each of these random variables will have a bar at the top because they're all continuous. And we just calculate them from first principles where we'd introduce n instead of the infinity signs. Okay. Then the term assurance, in this case, the endowment, sorry. So that needs to have a bar. So let's do that. That's a bar. Take all of that. Sorry. Okay. Doesn't want to work with us. Hey, oh wow. Okay. So we just need to introduce that A to the bar there. AXN. Okay. Without that bar. Okay. So the important thing is wherever there's a random variable, we put a bar. But since this is VNNPX, the term, the pure endowment, we don't put a bar. That that was the short of it. And then same as the deferred, again, there's a bar at the top, and then the approximation, whenever you want to change from approximation to non-approximation. Well, whenever you want to change from continuous to discrete, you use 1 plus I to the half. And there's also, I think, I to the force of over the force of interest, but that's a bit messy. I'd rather we use 1 plus I to the half multiplied by AX. And then everything that we've written here will apply for select values. So those are the formulas in a nutshell. Whole life, we have your whole life, AX, term assurance, AX, N bar, pure endowment, VNNPX, AX, N bar 1 at the end. You have your endowment, you have your deferred, and then you have immediate, right? Immediate, we'll do some questions on it as well, just so you understand a bit. So that's pretty much it. Um, Learn these, spend half a day or so learning them, understanding them, and then we will use the next video to apply what we've learned here. Yeah, we'll, we'll engage on the next video. Happy studying.